Hi everyone, I'm Michael Lange, a principal UI engineer at HashiCorp. I spent 4 years working on Nomad, another year working on HCP Packer, and now I work broadly across our application tools, which include Vagrant, Nomad, and Waypoint. Recently, I was in San Francisco for a leadership offsite, and I'm a big fan of mass transit, so when I'm in San Francisco, I prefer to ride the BART. It's their rapid transit system if you haven't been. After 2 long days of extreme businessing, ideas were percolating as I walked through the BART station. I thought about liminal space, the tracks, the ecosystem of vendors, advertisements, and the millions of people who ride the train just to get places with no particular deference for the BART one way or the other. Oh yeah, this is infrastructure, I thought. And when you look up, you see this: grates, fixtures, pipes, unassuming boxes, and miles of cable housing. How do they operate? What do their leadership offsites look like? When something goes wrong, who writes the ticket? How does a technician get dispatched? How frequently does a technician give a confident estimate only to be humbled by the deeper problem lurking beneath the assumed bad fuse? The good news is we live in the information age, and BART is a public service, so this is all quite searchable. Let's start with some of the recruiting material. BART recently published a video titled "Roll With Us, Train Car Electricians Are the Neurosurgeons of BART," which has received a whopping 1,100 views on YouTube. It follows Michael Thomas, whose outfit exudes electrician. I mean, just look at the pins. Anyway, he proceeds to describe a day in the life working on trains in the yard following a workflow of train is acting up, take the train out of service, electrician diagnoses the issues, and then the train returns to service. Later, we see our BART hero walk through the BART maintenance complex. And I'm forever envious of people who work with real, physical things. All of my gadgets exist as electrons. While doing this deep dive, I saw some fascinating things in the B-roll. Never mind the terrifying yet impressive caption on this one. What is this thing? It looks like a computer, but it also looks like an oven. Do people like this thing? Is it a rock-solid industry standard device? Or is this more akin to the bash script that someone wrote once upon a time as a one-off, but it's still being used 5 years later? I also just love these cones. There's no way that people who designed the traffic cone imagined it being used by shoving it over the sticky outy bit on a suspended train car to keep people from bonking their heads, but whatever works, works. But really what I love most about all of this is just how boring it is. Sure, we can geek out about the tools, we can get excited by the scale of it all, but there's no urgency, there's no intensity, there's no drama. This would not make for good television. But boring is what we all strive to achieve. A critical piece of this process that makes it so boring is that there's no debugging in prod. If a train is acting up, it's removed from service, replaced with another train on standby, and then the problem train can be diagnosed without the stress of service outages, loss of revenue, or the threat of real-world danger. How many of us have standby servers in our clusters? With Nomad, when an allocation acts up, it's totally possible to say, oh, it's fine. I'll stop it, and it'll get rescheduled. Or when a node acts up, it's totally possible to say, that's fine too. I'll mark it as ineligible, and then I'll drain it, and then I can remove it from the cluster, and then I'll let the scale set, or I'll let Terraform reconcile our infrastructure state. But are we doing this? There's such a large gap between implementing a best practice and knowing a best practice. And then there's an even larger gap between knowing a best practice and knowing to even know a best practice. And then I snap back to the offsite and I think about the lofty goals we all have when building products. The time to value for a new user should be no more than 15 minutes. It needs to be simple enough for a hobbyist, but robust enough for the largest enterprises. I mean, it's all well and good to have goals, but this elides the fact that what we do in our industry is hard. And fast is good, don't get me wrong, but learning is a journey. So, as a visceral example, let's check in on Michael Thomas again. Here he is, opening an innocuous panel on a BART car. Ooh, oh my. Yep, there it is, got the voltmeter out. It's escalated really quickly. And when I see this, I immediately kind of chuckle to myself and I think about something in our lives. where the simple Slackbot message like this about a failed task in CI, and how optimistic I can feel when I know that when I see that, I click through to the CI UI and I check the logs. But then, how terrible I feel when I see a cryptic error message in those logs and I must consult a system whisperer to figure out where to even begin to understand what happened. And if you are the system whisperer at your job, who taught you? How did you learn? How did you even know to think to learn? The trades are exceptional at teaching practical, applied knowledge that is immediately transferable to a job. The struggle with tech is that even though so much of our work is similarly applied knowledge, we're often applying knowledge that didn't even exist in the universe 2 years ago. And then other times, you're applying knowledge that's been around for decades, but no one cares to teach it anymore. I don't like calling people out like this, but Charity Majors is industry famous and like a CTO and stuff, so I think this counts as punching up. She once tweeted that she's on the verge of straight up deciding that SRE is inherently a senior role. I don't even necessarily disagree with her, but it gives me so much pause. How can it be that the people keeping BART running are technicians who can grow into the role from BART provided career training path or pathways from automated repair or military maintenance jobs? Yet keeping something or other.io online is senior work? Part of this is most certainly due to undervaluing electricians. But still, for as long as I have been alive, there has been an understood gap between being an electrician and being an electrical engineer. Back when Tesla was tinkering, I'm sure this wasn't true, like it couldn't have been, but it's definitely true now. In fact, generally in the world, I think it's understood that the people who maintain systems require less job training and experience than the people who build systems. So why are the people maintaining our software systems an exception? I think it comes down to a few key reasons. The first one is that everything in tech is changing so quickly, and it always has. Second, the pace of this change leaves no room for systematizing the interface between building and maintaining. We accepted this fate as an industry, and then we tried to put a bow on it when we decided that DevOps is good, actually. Third, we don't train people for applied software engineering. And I think it's clear that all three of these things are actually interrelated. It's been a decade or so at this point, but when I was in college, I was never asked to write a test, use source control, contribute to an existing code base, or even debug someone else's code. I mean, I learned an immense amount, and I don't regret my education. But at the same time, it was so distant from what happens on the job. And on the opposite side, there are some things I did in college that I've never had to do since, such as implementing a red black tree or writing in C. There are people in the world who do these things as part of their job, but it's not me, and frankly, it's not most of us. Meanwhile, as a UI engineer working at an infrastructure software company, I can't help but look at the immense network of code boot camps that make people good enough front-end and full-stack engineers to get hired. And then they learn the rest on the job. This is applied knowledge training. Why don't we see the same thing for SRE and DevOps? And if these programs existed, would we still be saying that SRE was inherently senior work? And to be fair, yes, technically there were search results, but it's mostly keyword stuffing, SEO opportunism. I don't think anyone here would agree like taking a full stack Node.js with React class is equivalent to knowing DevOps. And certainly taking a product management course isn't going to do the trick. And I should also mention certifications. There are a plethora of certifications, including HashiCorp's own. These are certainly applied programs. We have a wonderful education team, and our certification programs are amazing. But I think that our certification designers will be the first to tell you that learning a tool and learning a trade aren't the same. And you can argue that a general DevOps program doesn't make sense because there are no two systems that are the same. But an electrician or a plumber will tell you that too. Ultimately, we all have to learn on the job. Whether you're a teenager working in fast food, getting advice from a peer on how to handle aggressive customers, or you're a heart surgeon taking notes at some symposium. So how do we do that? How do we collaborate? How do we learn from our peers? A while back, I was reading about libraries as another form of infrastructure, and I came across this photo. I haven't been able to shake it. This is the plotting table in the ops room at the Royal Air Force Uxbridge. It was 60 feet underground and used to coordinate flight operations during the Battle of Britain in World War II. There's something so social about a big table grounding everyone's work. Even the most collaborative software tools today, like Figma and VS Code LiveShare, are still socially constructed as a bunch of people staring at their monitors while talking to each other. And that's the best scenario. What's more likely to happen is 5 people on a Zoom call, all muttering to themselves while they try to debug things. Maybe every once in a while they'll share an epiphany, but ultimately it always ends with someone sighing with the relief and just saying, "Fixed it." As our collaboration media degrade, so does our ability to learn via osmosis. How will we compensate? And as a real example for my own mistakes, here's a screenshot of the Nomad UI. We see the current status of allocations for this job, as well as a summary of the last deployment. At first glance, it looks neat and organized, but when you start looking closer, some of the details are confusing. Like in this screenshot, what is the difference between the 3 completed allocations and the 3 running ones? Or in this example, how are there 4 running allocations and 1 completed, yet 5 are desired and only 1 is healthy? And here it just, seriously, there are 0 failed, yet the deployment says failed. Only 2 are placed, but 5 are running, and now 39 are complete. I swear it does all make sense, but only if you know exactly what's going on. So coming back to this middle example, I've started calling this what happens when state machines collide. Packed in this space is the job state, each individual allocation state, including the running ones, and the completed ones from past versions that are no longer relevant, potentially long since been relevant. Then there's the deployment state, the canary state within the deployment state, the placement state within the deployment state, and then the health check state of allocations within the deployment. And the data for this actually comes from Consul. It isn't even a Nomad thing necessarily. So how does someone learn this? I mean, how does someone even explain this? I tried, but I can't imagine I just did a good job. No one will ever be able to intuit their way through this, especially if they're first giving it a serious look during an outage. Now, fortunately for Nomad, the Nomad UI team is looking into revising this. But for now, it serves as a good example of a dynamic that I see plays out in DevOps. And that's preparation versus performance. A lot of people in the world deal with this dynamic. Musicians perform at concerts after they prepare in rehearsals. Not only are they practicing their instruments and practicing their songs, but they're deciding on a set list. They're making decisions about what is safe to play and what isn't ready. How can they arrange compositions to include fewer pedals, auxiliary percussion, and maybe even fewer performers if they're taking a set on the road? Meanwhile, in software, a lot of us are way too confident when we write code. We ship things to prod and then get surprised when we have to keep it running. This would be like if we saw ourselves as instrument makers, not musicians at all, and then we get caught off guard when someone asks us to play something. Now, when you don't expect to perform, you're not going to even consider what it means to prepare. So if we accept that we will have to perform, then how can we prepare? Some of what I've seen at HashiCorp that I really dig includes game days. This is where our SRE team will run controlled outages in controlled environments to prepare service teams for being responsible for the new service they're about to deploy to production. This way, everyone has familiarity with both the tools and the processes for incident management. Production readiness matrices. This is where our TPM crew will ensure that before we deem a new service ready for launch, it complies with a set of requirements around observability, on-call rotations, support escalation, and load testing. But what I especially appreciate about the matrix format here is it's forgiving for small and fledgling services that don't need the same hardening that a service with 100,000 users or $1 million in annual revenue might need. And last year, cross-cutting concerns checklist. I think it's well known at this point that HashiCorp has a really strong culture around written artifacts, namely RFCs. Engineering leadership for Consul has introduced a list of Consul subsystems that all RFCs need to at least review before submitting an RFC for further consideration. This way, very early in the stage, before code is even being written, we can start to see how these subsystems might interact. And I can't tell you the number of times where new features don't play nicely with old features, and no one wants to find that out by way of a bug report. Another common technique for teaching and learning is pairing. I think every organization does this at this point, at least to some degree, and I'll admit that it's a lot harder when you're in a remote environment. But it's important to create this space to share and, as a teacher, be surprised. When writing docs, it's hard to know what level of specificity to write at. When pairing, questions and answers can be tailored to the moment. Returning to Uxbridge operations for a second. Here in the meeting room, we can see that pairing isn't new. Not only is pairing not new, but between the plotting table in the center here and the arrangement of people in the theater, we can draw a faint dotted line from here to platform engineering. There's a smaller circle of people who have read-write access to the table, and a larger circle that only has read access with which they use to make decisions. Another fun detail of this photo is that almost everyone in it is a woman. Women have always had ops roles for as long as ops has existed. Now I know what you're thinking. This was World War II. The men were fighting the war. They couldn't have also had these ops positions. And that's mostly true. I mean, women were also fighting the war, but it just proves my point. Women were always capable of this work, but it was socially unallowable until it was truly necessary. Now, unfortunately, this was also a time-boxed event. After the war, the Western world slunk back into its familiar gender roles. We saw the rise of suburbia, the nuclear family, and a general encouragement of domesticity. This photo at Uxbridge was taken 24 years before Richard Feynman would infamously say, "I didn't realize the female mind was capable of understanding analytic geometry." Feynman was 48 when he said this. Now, he was recalling a moment from when he was at Cornell, when he was in his late 20s. But still, even then, that would have placed the epiphany after World War II. This all may sound like a digression from DevOps, but there's a lesson here. History is both facts and context. Critical theory teaches us these social constructions aren't to be ignored. Speaking of which, whether or not Feynman should have known better, given history, it's going to be left to an exercise for the listener. So, critical theory is, and it has always, critical theory is a lot of things, and over time it has somehow managed to become even more things. Philosophy just kind of generally has a tendency to become overwhelmingly intangible. So I want to ground this connection in retrospectives. Because underneath critical theory is the position that objective reasoning has withered away and subjective reasoning now rules everything around us. Briefly, objective reasoning states there is a fundamental truth that defines an end goal, and that end goal should drive our purpose. Subjective reasoning states that reasoning is situational and can justify our means to any end. So without the purity of objective reasoning and the fundamental truth it presumes we'll all gravitate towards, we end up with many forces co-opting our lived experiences to justify the end that they want to realize. So let's imagine a retro for an outage. The outage did happen, we know this. And there was an objective root cause. This can be objectively reasoned about to determine, say, that it was a memory leak that caused an out-of-memory error on a critical service, which then caused the orchestrator to reschedule the service. But at this point, the service was partially out, so that load was balanced onto the remaining instances, which caused a cascade of ooms. Now there's a total outage. And then there was a thundering herd of reschedules, and this caused resource contention on the nodes in the cluster, and all of these noisy neighbors caused other services to start failing in a horrifying domino effect. Okay, so if we look at the evidence here, if we look at it all at once, we can objectively blame the memory leak, which would be the app developer's fault. Further, we can objectively blame the constraints of how the service was run, since the single instance of the service going down shouldn't have caused a cascading failure. This may have been the SRE's fault. Finally, we can objectively blame the orchestration platform itself for running on margins so thin that there was no grace for this category of failure, causing other services to start and fail. And this is all well and good and all, but these objective truths occurred in the subjective social contract of a company. The app dev can say, We had to hit a deadline. There was no time for rigorous testing. And they'd be right. The SREs can say, well, we configured the service the best we could with the information we had, but we couldn't predict load, and we deprioritized exploring autoscalers because of the same deadline. They too would be right. The platform engineers can say, we were told to cut our operating costs. This was a known risk that we took until we get a bigger budget. And they'd be right. So within the context of the company, what is actually at fault? It's starting to sound more like an aggressive deadline and a lack of budget than developer negligence like it sounded like a minute ago. But if you confront management about this, they'd likely say that the deadline and the lack of budget are related. We need to generate more revenue or close a round of funding if we want bigger budgets. So why do you think the deadline was so aggressive? So the objective truths here about the memory leak, the constraints, and the cascading failure aren't particularly useful in the diagnosis. It's the squishy membrane of the contextual circumstances that tell the interesting bits about what actually happened. How can we add more context to our diagnoses? First, let's go back to critical theory, this time as it relates to literary criticism. When critiquing literature, the kernel of objective truth is the text itself. We know it exists. But if we're thinking critically, then we know that it alone isn't self-explanatory. All texts are a product of their time, and we can glean insights from the related texts, including reviews, critiques, and the text-to-text references. The term for this is transtextuality, which was coined by Gerard Genette. Under the umbrella of transtextuality is the subtype paratext. The paratext of a text is the surrounding margins, graphics, prefaces, forewords, and acknowledgments of a text. The assertion here is that the paratext can influence our interpretation of that core text. So as an example, what do you think of this book, The Art of Doing Science and Engineering, by Richard Hamming, which was published in 1997? Judging by the cover and the date, maybe you think this is an old textbook, possibly even irrelevant now. But if you knew Richard Hamming was a famed mathematician who worked on computation at Bell Labs, and that this book was published a year before his death, does that change your perception? What if Stripe republished the book in 2020, updated all the charts and graphics to be modern, and then gave it this sweet cover art in its own little mini site? And what if they also included a foreword written by the esteemed thinker of our generation, Brett Victor? Does that change your perception? And if you knew that in Brett Victor's wiki photo, he carried pins in his shirt pocket, just like Michael Thomas from that BART video, does that lend credibility to whatever the hell I'm talking about right now? Or is it just a funny coincidence? Okay, we're talking about retros. How does transtextuality apply to retros, or deploying software at all for that matter? I think this definition of paratext sums it up. The fringe of the printed text, which, in reality, controls the whole reading. Philippe Lejeune. I think it's increasingly important to capture context in our day-to-day work. And as a result, it's increasingly important to be critical of synthesized and aggregated metrics, like number of Sev1s this quarter, or even hours of impact. Some tools that I like, that I'm looking at when I have these thoughts are Blameless, being able to chat in real time in Slack, and then procedurally generate an artifact that crystallizes an incident. It's huge. It makes the journey from the top-line metric, Sev1s this quarter, to the thorough critique of our performance over the quarter much more manageable. And Moment.dev. Although this tool is in private beta, the idea of using interactive notebooks for checklists and runbooks makes space to tie the function of a task with reasoning about why we do the task and why we do it the way we do. When docs are separated from where we act out our performances, they're easier to ignore and easier to deviate from. Datadog also has nice notebooks, but theirs are targeted for ad hoc analysis, so I still like them, but this idea of having it integrated into your runbooks is just extra compelling to me. And third, open context. Now, providing complete context for DevSecOps, that's clearly an ambitious goal, but a hypertext representation of the relationships that surround incidents and security protocols, it's exactly what I want when I'm thinking about the squishy subjective membrane that envelops a core truth. All right, now, I know that for all I talked about applied learning, this talk has been just a touch in the clouds. But if I had to assign an action item, I would say, please consider the work around the work as just as important as the work itself. In tech, we love to claim we're building the future, and I do genuinely believe that this is true. But I think while we're doing so, let's borrow from what has worked in the past. Thank you.